Alright folks, today what we're doing is word problems involving quadratic functions, parabolas. This problem right here, even though we haven't done this, a lot of you were reading it and freaking out. I want you to use the clues in the problem to see if you can determine what it is they're asking you to find about this parabola. How do I know it's a parabola, first of all? It's got an x squared. It's definitely a frowning parabola. Now, it says P is the profit. P, what normally do we put here? Y. So that means all the Y values on this problem stand for what? Profit. My Y values are profit numbers. P is the profit from selling X units of sandwiches. So guess what X stands for? Sandwiches. Okay, so X units of sandwiches. Guess what the X numbers stand for in all of these points on this parabola? Sandwich. Number of sandwiches. That's important. Understanding what the X's stand for, the independent, and what the Y's stand for is going to help you answer these questions that we're going to do today. So we're putting in how many sandwiches she sells. We're doing this math to that number of sandwiches, and what's coming out is how much money she's going to make, how much profit she's going to make. Now, look at the question. How many must she sell? How many what? Sandwiches must she sell to make a maximum profit? There's a clue word in there that should tell you what it is we're looking for. What's maximum mean? Vertex. We are going to need the vertex of this parabola. Please find the vertex. Go ahead and just give me the whole vertex, and then we'll talk about what each part of the vertex means, and then we'll answer the questions that were asked. Because when they ask you about a vertex, remember a vertex has an X number and a Y number. Very rarely will they say, find the vertex of a parabola. They're going to ask you some kind of word problem, and they might want the X value, or they might want the Y value, and you've got to know what part it is they're asking for. I see some people who don't look like they're finding vertex. What is the X value of the vertex here? Okay, so that's the part you do in your brain. The opposite of B divided by 2 times A. Then you turn to your calculator. Please, if you haven't already, please reset your calculator. I want you to reset your calculator because changing the window is part of our lesson today. Okay, so we're going to put in the function rule. Y equals negative x squared plus 50x minus 350. And we just figured out the x value of the vertex is 25, so I'm going to tell my table to start at 25. 275. Now, if you just gave me the answer to this question as 25, 275, that doesn't tell me that you really understand the different things it's asking. Look at the first question. How many sandwiches, I left the word out, must she sell to make a maximum profit? 25. 25 sandwiches. The first thing it asked me for was the X value of the vertex. Then look at the next question. What is the maximum profit? $275. Yeah, in other words, if she sells 25 sandwiches, she will make her maximum profit of $275. Okay, so that's how a typical word problem could sound. Now, this is what we're doing today, guys. We are looking at problems involving real-life parabolic functions. My nails are blue. Read this question, let it sink in for a second, and I want to talk to you about some things. These are notes. Word problems of parabolic functions. Doesn't that sound so intelligent? A parabola is just what we've been looking at. These guys. Okay, so read this question. Now, in the setup of the problem, they're trying to help you determine what the x's stand for and what the y's stand for. Think about that. You can just put word problems for parabolas. I don't care. That's fine. Word problems for parabolic functions is fine. Okay, it says the height of a rocket that was launched into the air at 160 feet per second is a function of t, the time in seconds after the rocket was launched. Sounds very complicated. It's not as bad as it sounds, I promise. The height in feet is determined by this equation. What does h of t mean? Y. Okay, so let's talk about what do you think the t's stand for and what do you think the outputs stand for? T stands for time. What's coming out? What does the y stand for? Height. In most of the problems that we're going to do involving real-life parabolas, it's usually about a rocket going into the air, or a softball being hit into the air, or a golf ball, or something where it's being launched into the air and eventually it's going to come back down. So on these problems, input is your time, output is your height. The height of the object will depend on how long it's been since it was either hit if it's a softball, or kicked if it's a soccer ball, or launched if it's a rocket. It's a function of however much time has gone by determines how high it's going to be. And these things are going to go up in the air and eventually come back down. Okay, so when we look at these problems, we're normally just focused on the first quadrant. So this is important, guys. Everybody reset your calculator if you haven't already. Second plus 712. Then go to y equals, and let's put this function rule in there for this rocket. Y equals negative 16x squared plus 160x plus 4. Now, if I try to look at this picture in my t-chart, I hardly see, not my t-chart, in my graph, I hardly see anything. Because this doesn't make sense for this real-life problem. Real-life parabolas usually only occur in the first quadrant. We got a whole bunch of space we don't need, and what's happening over here is it's off my screen of my calculator. I can adjust what I want to see in my calculator. And let me just tell you, for most of these, for the ones involving something going up into the air, usually for time, I usually like to go anywhere from 15 to 20 seconds, and I'll show you what that means in a minute. And for height, I usually start around 150 feet high, and I see if I can see the picture. So just keep that in mind. Now, where do I go to adjust my time values and my height values? In other words, my x's and my y's. I'm going to go to Window. When you're in Zoom 6, which is the standard window, Zoom 6 is standard. Your x's go from negative 10 to positive 10, and so do your y's. But that doesn't make sense for this problem. Now, if I go to Window, I can see my standard screen. My lowest x value is negative 10. My highest x value is positive 10. That's not going to work for this. And your x's are almost always going to be your times. Now, I don't need negative seconds. I usually make my minimum time 0. Sometimes I make it negative 1 just so I can see where the x and y axis intersect. So I usually make my x minimum negative 10. Negative 1. 0 is what would really make sense because we're not going to go back in time. We're starting at 0 seconds. As soon as I launch the rocket, that's when my time starts. But I usually put in negative 1 just to see a little bit of the axis. My x maximum, that's the maximum time until the rocket's going to do what? Land. It's going to go up in the air, then come back down. It's going to eventually land. So the time maximum is the time it takes until it lands. I usually put time anywhere from 15 to 20 seconds. I'm going to put 20. Now, the next thing says the scale. That just means the x's are counting by ones. I usually don't change the scale. Now let's talk about the y's. Remember, y's in these problems are heights. Do we need negative heights? No. What's the lowest height you think the rocket will ever be? At 0. It's not going to burrow into the ground. The lowest height is going to be when it comes back down to the ground and lands. So for y minimum, I could put 0. I usually put -1. I just like to back it up just a little bit so I can see the x and y axis. What do you think y maximum is going to stand for? The height. The highest height it's going to get to. And I don't know how high it's going to go. I'm just going to guess. I usually start with 150. And then the y scale, I don't mess with the scales usually. Now, look, my picture is getting better. But this is just a guessing game sometimes. What do I need to change? The height. I didn't go high enough. I went to a height of 150, but this thing is still off the screen. And look at my time. Did I put in more than enough time? Yeah, it didn't take quite that long. So I'm going to back up my time to 15 seconds. You don't have to, but I just like my picture to look nice. And my y maximum of 150 was not nearly high enough. Okay, so somebody said let's try 250. It's getting better. Still can't see the top of that thing. That means this thing is going higher than 250. What do y'all want to try? 550. Let's try 500. Yeah. So our window doesn't have to be exactly the same, but you have to be able to see the picture. Ramiro, you need to be doing this with me. This is not optional, guys. If you're not following along here, you're going to have a real hard time passing the next quiz and the test. It's better than Zoom. What Zoom does is it just zooms out the whole thing, and it kind of distorts the picture. So I prefer doing this to just zooming out, because then it's real hard to see the picture. I like a nice, pretty picture. So on our window, our time values, we changed from -1 to 15 seconds, and our height values, we changed from -1 to 500 feet. Are y'all with me there? And sometimes it's just a guessing game, but just in general, I usually start around 15 seconds when I'm doing the x values, and I usually start around 150 when I'm doing height, and I might have to go higher or lower, it just depends. No, the time is the x's, the height is the y's. Now, let's talk about some of the types of questions that I have asked you when it wasn't attached to a word problem. What have we found on parabolas? We found roots. What in the world do you think the roots are going to do for me here? Show where it starts and ends. Most specifically, where it ends. Because this thing, if you looked at the whole parabola, it's going to have a negative root and a positive root. Does the negative root really make sense here? No. So I'm looking for the positive root, because that's going to tell me where it ends. What else have we done? Vertex. What do you think the vertex is going to tell me? It's going to tell me the maximum height, and it's also going to tell me what? The time it took to get to this maximum height. The vertex is going to tell me how long it took to get to its maximum height, as well as how high this rocket will go. The highest height it's ever going to go. So those, oh, and what about the y-intercept? We never really talked about y-intercept. What is the y-intercept? The y-intercept is usually where it starts. What is the y-intercept just looking at this equation? +4. That's this right here. That's why it's not starting on the ground. What does the 4 stand for in this problem? Yeah, it's the launch pad. It was launched from a platform that was 4 feet off the ground. So this thing started at 4 feet off the ground, but it eventually comes back down to the ground. Unless it goes straight up and comes back down on the platform, which it probably won't do. Okay, so the y-intercept is usually where it starts. The x-intercept, the positive x-intercept, is usually where it ends, where it lands. The vertex is the time it takes to get there and how high it's going to get. And then I can ask you a variety of other questions as well. So are you ready to do some problems? Here is your first question. What is the maximum height of the rocket? So what am I asking you about here? The vertex. Specifically, which part of the vertex? The y value. That's up to you. I mean, this video is going to be on Schoology. It's up to you if you want to write the problem. Okay, so this is absolutely a vertex problem, and it's specifically just one part of the vertex, the height part, the y value. How do you find vertex? Half brain, half calculator, opposite of b over 2a. Now, real quickly, guys, I want to show you something that came up because I don't want you to do this mistake. Some kids are too calculator dependent, and they're not thinking about how they're entering in something into the calculator. Look what I had. Somebody did this earlier, and I meant to talk about this. They did negative 160 divided by 2 times negative 16, and the calculator gave them an incorrect answer. What do you think I did wrong here? Absolutely. You got to put parentheses around the denominator. The calculator is following order of operations. It's doing negative 160 divided by 2 and getting negative 80. And then it's multiplying negative 80 times negative 16. And that's really not what you're supposed to do. It's negative 160 divided by, I've got to put parentheses around the whole denominator. 2 times negative 16. Now I'm telling the calculator to get the denominator first and then do the division. That's correct. Now, is that the answer I was looking for? No, that's the x value of the vertex. Okay, so now how do I find the y that goes with it? Go to table set, tell it to start at 5, or I could do calculate value. So my whole vertex is 5, 404. But if you put that answer to this question, Zoe, I would put a big fat X, and then I'd get mad at you for falling asleep. What is the answer to my question? 404 feet. That's the only answer I want to see. If you put 5, 404, that doesn't tell me that you know that the y value is actually the height and the x value is actually the time. I do want you to get in the habit of putting units here. I wouldn't be as mad if you put 404 with no feet. No, I wouldn't be wrong, but I'd probably take off a point for units or something. Now, what could be a follow-up question? To still using vertex, what's the follow-up question? Yes. How long did it take to reach its maximum height? And we already know the answer. It wasn't 5 minutes, it was 5 seconds. So do you see how I can split a vertex question into 2 separate questions? This one is. Okay, are we good with that? Now, keep the vertex in mind because here's another question that's related to vertex. What else was related to vertex? The axis of symmetry. So I might just randomly say, what's the axis of symmetry for this problem? X equals 5. There was something else that was related to range. Now, this range is different, guys. We are talking about a situation that looks like this. The range is not like what we've been doing. It doesn't go on forever to the top or the bottom. It has a top and a bottom. So the range of this problem is one of those back to where we have like a in-between values. What is the lowest y value I'm ever going to have? 0. That's when it landed on the ground. It's not going to burrow into the ground forever. It doesn't have arrows like the ones we've been doing. Okay, so my lowest height value is 0. That's right here when it landed, right? Now, what's my highest y value? 404. We just found the highest y value. So if I asked for range, it would be 0 is less than or equal to y, which is less than or equal to 404. That's my lowest height, that's my highest height, and then it reaches all kinds of heights in between. Does that make sense? Okay, so I definitely asked about vertex. Vertex could tell me axis of symmetry, it could tell me the time it takes to get to maximum height, it could tell me the actual maximum height, and it also determines my range. Well, if you start with the smallest height and end with the highest height, yes, you would use less than. If I wanted to start with the highest and end with the lowest, I would use greater than. Now, what else have I asked you about parabolas? We talked about vertex. What else have I asked you? Domain, which is related to the roots. We're going to get there too. I have definitely asked you about roots. This parabola, this equation has 2 roots, absolutely, but what's the only one that makes sense to the problem? The positive root. Find the positive root of this problem. Zoe, wake up. You're going to tell me tomorrow that you don't understand this, and I'm not going to feel bad at all. Find the positive root. The negative root doesn't really make sense here because this problem is really only happening in the first quadrant. So the positive root is going to help me determine some things about this function. How do you find any root? Not trace. Well, first of all, you have to put in what? You have to put in y equals 0. And then you calculate where they intersect. Now, if your calculator is on the negative root, then yeah, you're going to have to trace over to the positive root. But you have to make sure you put in y equals 0. This isn't going to work. Second function, calculate intersection. So I'm looking for this point right here. First curve, second curve, guess. Luckily for me, my cursor was closer to the positive root anyway. And what is it? 10.024 what? Feet? Seconds. Comma what? 0 what? Feet. Yes. So what does that mean? What is this positive root telling me? How much time it took to land. This is how much time goes by before this thing is back on the ground. That's what a height of 0 feet means. It's back on the ground. So that's what the question could be. How long until it lands? So how long until this thing lands? 10.024 seconds. That's how long until it lands. And yes, that's also going to help me with my domain. The domain of this thing is not all real numbers. It does not go on forever. This real life problem is only occurring in the first quadrant. What's the lowest time value that makes sense in this problem? 0. That's before we launch the rocket. We don't start counting time until the rocket is launched. What's the highest time value that makes sense in this problem? 10.024 seconds. What happens there? It lands. We're done. Experiment over. Rocket launch over. So the domain can also be determined by looking at your roots. In this case, my domain values go from 0 all the way up to 10.024 seconds, and all of the other x's are somewhere in between. So we talked about what a vertex question would sound like, what a roots question would sound like. Axis of symmetry would pretty much just be axis of symmetry. We talked about domain, we talked about range. Now, look at this problem. When will the rocket reach a distance of 250 feet off the ground? What am I telling you? I'm telling you a y. How do you know this is a y? Because it's a feet measurement. You're putting in time and you're getting back feet. So I'm not giving you an x value. An x value would be a time value. I'm giving you a y value, a height. How would I do that? Yeah, we've already got our function rule in there. We're not finding the zeros anymore. We're finding the 250s of the function. We want to know, when did it get 250 feet off the ground? It got there twice. Once on the way up and once on the way down. It got there right here and right here. So I'm looking for two different time values. I'm going to calculate where they do what? Intersect. First curve, second curve, guess. Mine happened to be on the way down one, which was 8.102 seconds. I still have to find the other time it got that high, so I'm going to hit trace and go over to the other side. Do it again. Second function, calculate intersection. First curve, second curve, guess. 1.897 seconds. Okay, and that would be set notation. Now, they usually only like to ask one question at a time, so this is how they could ask it. What was the first time it reached a height of 250 feet? That would be this one. What's the second time it reached a height of 250 feet? That would be the one on the way down, the bigger one. Took more time because it kept going up. It reached its maximum height, and then it started coming down. Okay, here's another question you might see. How high will the rocket be at 7.3 seconds? What am I giving you there? I'm giving you an X and asking you for a Y. I'm giving you a time and asking you for a height. That's an X value. It's easy to control the X's. Where do I go? I go to either table set or calculate value. I could go to calculate value. I know the X value I want to use is 7.3 seconds. How high is it going to be? 319.36. What? Feet off the ground. Absolutely. So that's everything we've been doing. It's vertex. It's zeros. It's roots. It's domain and range. It's giving you an X and you find the Y. It's giving you a Y and you find the X. Please reset your calculator. We're going to start over with a different scenario. We're going to look at a softball question. So everybody hit second plus 712 because I want you practicing changing your window. Everybody reset your calculator. Second plus 712. All right, now we've got a different situation. Read this situation. It's not a rocket anymore. It's a softball. The ones that go under, let me see if I can think of a... I believe all of the real world scenarios that I've seen involve frowns. But that could be maybe diving under the surface of the water. Would be one that would go down instead of up. Yes. Now, here's two things I wanted to show you. This is something they like to do. Look what they did. They switched the order. You could leave it exactly like it is and put it in just like that. Or some of you just really like your x squareds first. If you want to rearrange the terms, that's fine. I usually just leave it like they had it. However, when you go to find vertex, keep in mind that 80 is your B value. Negative 8 is your A value. See what I'm talking about? A is always in front of the T squared or X squared. And B is always in front of plain old X. Some kids wanted to rearrange this. I don't care what you do. But I did want you to notice that they, for some reason, they like to do that. Switch the terms around. Okay, so now somebody is throwing a softball at a batter. Time starts as soon as the bat is launched into the air. The ball is launched into the air. It's going to go up to its maximum height and then eventually come back down. Can you tell me something about the height of the person hitting the ball? Well, he's probably not 4 feet tall, but the bat is 4 feet off the ground. That's the +4. That's the y-intercept right there. So it's starting at a height of 4 feet. It's going to go up, and if nobody catches it, it's going to come back down and hit the ground, just like the rocket did. Do you think it's going to go as high as the rocket? Probably not. Okay, so let's put that into our calculator. I just left it like they had it. 80x minus 8x squared plus 4. I'm going to ask you a question. You've got to determine am I looking for a 0, a root? Am I giving you an x and want a y? Am I giving you a y and you want an x? So here's my first question. Find the maximum height of the softball. What do you think I'm asking for? A vertex. And specifically what part of it? Just the y value. Remember that little trick I taught you yesterday? You can calculate a maximum in the calculator. And I didn't change my window. Oops, let's change our window. I forgot about that. See, look at how I can't hardly see this thing at all. Because I don't need all these quadrants. I need the first quadrant. So I'm going to go to window. What did I tell you usually to do with time? I usually put -1 as my lowest, and I usually go to about 15, and then I see if that works. If not, I change it. For the height, what's my lowest height? I usually put -1. Really, the lowest height is 0, but I usually put -1. What's my highest height? I have no idea. I usually start around 150. Can I see it? Not quite, but it's getting better. What do I need to change? My maximum height isn't high enough. I went to 150. I need to go to... I'm going to try 250. 250 worked. So you just got to play around with your window until you can see this thing happening in the first quadrant. Time, I usually go from -1 to 15 or 20. Height, I usually go from -1 to 150 or 200, and then I just play around with it until I can see it. I don't usually change, I don't mess with the scale. I leave that alone. All right, now I can see this thing. I just asked you the maximum height this thing is going to get. That's the vertex. So I'm going to do calculate maximum. Left bound, I just need to make sure I'm to the left. Right bound, I need to make sure I'm to the right. And then don't stop till it says maximum. What's the maximum height? No. 204 is the maximum height.
I thought you do like you find the x and then you do table set or whatever.
You can do that.
Okay.
But 5 is what? 5 is the time.
Okay, -8 times 2 is
Yeah, okay, if you did it the other way, so you would do opposite of b divided by 2 times a. That's -80 divided by -16, which is 5. Then look at your table of values. Oh my goodness, former student. Oh my gosh, I recognize you. I'm good. Are you here for the fair? Yeah. Awesome. ROTC. Y'all need to sign up. Tell them how. Oh, let me pause this. Y'all have.
I get it. You're literally about to run out of time.
Okay, I forgot where I was. What were we talking about?
We were talking about
Oh, okay, we were doing the vertex, the half brain, half.
what happened?
We were doing the vertex, half brain, half calculator. So. I'm going to have to do this whole recording over. Okay. So the opposite of b over 2a would give you 5, but you need to understand that's not the height number, that's the time number. So then I would go to my calculator, look at the table of values. I would tell the table to start at 5. Oopsie. At 5, and then look across from the 5, and there's my height number. So if I ask you this question and you give me 5,204, I can't give you credit. What is the actual answer to the question? 204 feet. No. I just want 204. No. If you make me pick, I'm going to pick the wrong one. It's just I need to know that you know what part of the vertex they want. Now, if I asked you how long does it take to get to its maximum height, that would be 5 seconds. And if you put 5,204, that looks like 5,204 seconds to me. It's just 5. Are we good with that? Okay, back to our question here. When will it land? When will it land? Please find that. What am I asking? The positive root. When will it land? It's going to land right there. I want the positive root. So I put in y equals 0. And remember, I want the positive one. I'm going to calculate where they intersect. First curve, second curve, guess. What did y'all get? 10.049 what? Seconds. Are y'all with me over there? You're about to have a worksheet on this, and you're going to take a test like this as well. Probably Friday. Okay. Tell me the domain of this situation. It is not all real numbers. If it was a regular parabola with arrows and everything, it would be all real numbers. But this real life situation starts here and ends here, so the domain nor the range are all real numbers.
Would you always start at 0 and then put the other number, or would you use the y?
I usually start with the smallest value. What's the smallest domain value that makes sense here? 0 time before we hit the softball. What's the highest time value that makes sense? 10.049. That's when it landed right here, and all of the other x's are in between. What's the range for this situation? The lowest height that makes sense is 0. The highest height is dependent on what the vertex was, which was what? And all the other y values are in between. That's the range of this situation. Now, next type of question. When will this be 50 feet high? When will it be 50 feet high? What do?
You go to the x, y equals, put 50.
You go to y equals and put in 50 feet, and you see where they intersect. It's going to happen twice. Once on the way up and once on the way down. And I also could say, where will it be at 2.7 seconds?
You can go to second table set 2.7.
So what do you do there?
Go to table
You can just go to table set in 2.7 seconds,
second table.
and it'll be at a height of 161.68 feet. Okay, so those are all the things you got to be able to do. Your homework is a worksheet. Please remember we got to add an exponent to the worksheet. This video will be on Schoology. This very much interrupted video will be on Schoology.